winter is coming.
Though, not really here in Israel. But no matter where you are, the arrival of winter does inevitably mean a lot of time indoors. But fear not, because in this video, I'm going to share with you a bunch of big, functional 3D printing projects that you can do to stay busy, get organized, and scratch your need to make and create all winter long. We'll cover a handful of larger, more commitment-oriented 3D printing projects, each functional in its own different way, to level up your home office, your workspace, or your workflow. And we'll even revisit some of my favorite project ideas from past videos, and I'll share some new tips and tricks that I've learned since we last talked about them. Oh, and by the way, you'll even get to see a studio build update, and depending on how much I can get done by the time this video comes out, maybe even unveiling of my all-new combined workshop and recording set. Let's get after it. I don't know about you guys, but I hate an echoey room. Even if I'm not recording video, who likes the sound of their own voice echoing during Zoom calls? That's why the first project on our list is going to be to cover my walls with some 3D printed sound treatment. Now, as you might know, there are really two elements to improving the acoustics of a room. There's diffusion and absorption. The first is about scattering the sound waves, and the second is about, well, absorbing them. Fortunately, 3D printing can help us with both of those objectives. First, let's talk about these 3D printed diffusion panels by Widgets. A couple of months ago, I saw the square diffusion panels that he'd uploaded, and I was really impressed. This design actually cleverly takes advantage of vase mode, printing upright to save on both filament and print time. Now, I love this idea, but I'm also a firm believer in the indisputable fact that
hexagons are the bestagons.
So I tried to model up my own versions of these panels, but I wasn't really happy with anything I came up with. So at that point, I reached out to Dave Makes Stuff, who was kind enough to begin generating a bunch of really cool designs on his own, and I commented on the original design by Widgets. Now, Dave's designs turned out really incredible, and I'm going to link them below, but they didn't really meet some of my specific needs, as I'll get into in a second. Fortunately for me, though, Widgets was kind enough to oblige by creating some really cool hexagonal designs, and we were off to the races. Now, to cover this wall, I needed a lot of these things, like 4.5 kilos worth of filament. It's at this point that I do need to thank the folks over at Kexeld, who sent over about 20 kilos of their fantastic filaments, both for this project and for a bunch of other upcoming projects that you'll see only if you subscribe. Now, I had a great experience printing this filament out, and Kexeld also makes a ton of the very advanced professional grade filaments like the ones I covered in my last video, so I'll link you guys to their web store below in case you want to check them out and support the folks who make projects like these possible. Now, let me be clear about one thing here. I have no doubt that either the original jagged design or Dave's more intricate designs would be much more effective than these ones at actually diffusing sound. But because I'm going to be using these as a background for recording videos, I didn't want to have so many shadows and sharp angles when I point light at it. Additionally, because I was going to be doing a rather large wall, I really wanted to choose a design that was economical both in terms of filament and in terms of print time. And that really is the genius of this design. Printing it in vase mode meant that I could get a ton of them done quickly, but because the dimples in the back actually touch the back, they're actually pretty strong. So aesthetically and economically, they fit the bill, but will they actually diffuse sound? We're going to find out in just a second, but before we do, we need to deal with sound absorption. In my space, I decided to create a couple of these absorption panels out of scrap wood and some mineral wool. But if you're following along and you want to 3D print some of your own, you're in luck, because I also have designed and uploaded some designs for modular hexagonal acoustic panels. You simply print them out, fill them up with insulation or old clothes even, and then wrap them in the fabric of your choice. Now, I've printed and put about 6 of these throughout my own studio with unused scraps of insulation from the big panels, but for this specific set, I decided to use large panels on this inside wall and on the ceiling because you're not actually going to see either of them on camera. Okay, hang on, because I do need to take a moment to thank this video's sponsor, PCBWay. Like you, I always prefer to 3D print as much of my project as possible, but for some projects, there are just things that you cannot 3D print yourself. Whether that's industrial grade MGF nylon parts, CNC machined aluminum, metal 3D prints, or custom designed PCBs, the folks over at PCBWay have you covered. They offer a wide range of high quality fabrication services at great prices with super fast turnaround. And if you don't know how to design PCBs or CAD models for CNC machining, don't worry, because they actually have a marketplace of ready-made projects that other people have designed and submitted. PCBWay has been a longtime sponsor of this show, and they're just great people to work with. So to check them out and support the people who make this video possible, visit the link in the description. But now, the moment of truth. These panels look good, but are they actually functional? Here's the before and after without sound treatment, because we sound treat these videos. So let's have a look. So this is before. We have no acoustic panels. These printers aren't running. There's one printer running over there. I definitely feel less sound coming from behind me, and any echo I'm getting is up here where I haven't put panels. It definitely feels better in this little alcove where I'm actually going to have the microphone. So that's good. Personally, whether or not these are as functional or professional as professional grade solutions or Dave Makes Stuff solutions, I love the look of these panels, and I cannot wait to record a bunch of time lapses with them as the background. But let me know what you think in the comments below. Up next, let's look at a functional 3D printed solution for a very common 3D printing problem: filament storage. You might remember that during my previous functional 3D printing challenge, I printed and installed a massive 4-row RepRack filament storage system by Pooch over at RepKord, and I've been loving it. It is without a doubt the most cost-effective and convenient way to store filament out there. So if you're still storing your filament in stacks or even on shelves that take up floor space, I highly recommend that you start out by printing the RepRack. You have a lot of options for doing this, from using wood for French cleats and laser cut brackets to fully 3D printing both the brackets and the wall-mounted cleats. Whereas last time I used wood for both the mounting and the brackets, this time around I wanted everything behind me to be white in order to absorb the colored lights. So I went with 3D printed cleats and brackets. I also choose to use these IKEA curtain rods, although I need to clean them, instead of just basic conduit because I didn't want to have any glare in my background. I think this RepRack turned out amazing, but we're not done. You see, one of the things that I don't like about my primary RepRack in the other room is that I cannot print directly from it, which means a lot of time taking filament down and hanging it on rollers next to my printers. But most of you don't have 160 plus rolls of filament and 20 printers, meaning that your setup might look more like this one. 1 or 2 printers on the table, plus a handful of rolls of filament above it. When it comes to printing from this rack, you do have a variety of options. If you want to keep it simple, you can just install the original slip rods by Pooch on there to 3D print directly from the rack. As the name suggests, these rods just take advantage of the slippery nature of PETG, and they let the roll slip. The downside with this is going to be that you're going to end up spending a lot of time reaching up and manually rewinding filament spools. Now that might be okay if you're only printing with one color at a time, but if you're running a multi-material system such as the new Prusa MMU3 or this Physek Enraged Rabbit carrot feeder that I've been working on, you're going to need a solution to rewind your filament rolls and avoid tangles. Side note, I actually considered adding a whole section in this video about the ERCF project because it's a really fun one to do on a rainy day or 5, but I'm not really sure how interested you guys are in adding open source multi-material capability to your own 3D printer. So please let me know in the comments below if I should do a full video about this or just cover it in some shorts. Now, in the past, when using these types of MMU systems, people have used all kinds of intricate filament buffer systems like the Enraged Rabbit carrot patch, but today there are better, simpler, and more aesthetically pleasing solutions out there. One such solution is the RepRack Auto Rewinder by Jerrari. The idea here is that you have a bracket which sits on either the RepRack or even a table, and then holds 2 rollers, one front and back. Inside, these rollers have a series of coils which wind up one after another to store energy in the form of rotational energy and create tension on the filament. Then, when the filament is released or unloaded, the rollers spring backwards, rewinding your filament spool. Actually, this is the same exact principle that allows the new Bamboo Lab AMS Lite to rewind the spools without needing a separate motor in the spool holder. Now, I've been in close contact with Jerrari, and he has been so awesome in improving his designs, and I have to say that these rollers are really promising. He and I are actually both testing a bunch of different tweaks and versions. For example, the original version takes advantage of the slippery nature of PETG and allows the spool to slide on the roller once it's fully wound. But another newer version makes use of a clutch at the end of the coils and then increases the friction on the roller itself by adding Plasti-Dip sprayable rubber to the roller, thus allowing the coils to fully wind up and relying on the clutch to allow continued rotation. Now, so far, I think I prefer the version without the clutch, but fortunately, if your tolerances are right, then you can just swap back and forth by simply removing all the coils and replacing the first segment. Now, as you can see, I have not yet had the time to complete programming the ERCF or printing all of these out and assembling them, so I can't tell you how well it's going to work together with that setup. But I can definitely say that if you want to print directly from your RepRack, whether or not you have a multi-material unit, this is a welcome improvement over the standard slip rods. I love how it automatically rewinds my filament and prevents it from getting caught on, say, the corner of my printer. So it might be worth printing one or two out just to use with your RepRack for that reason. Just be warned, if you're going to do as I am and print out 10 to 15 of them, it takes a lot of time to assemble, spray paint, and install all the many pieces. Like many hours. More hours than I want to admit. Plus, it does use quite a few M3 nuts and screws, so gear up before embarking on this project. My love for Zach Friedman's Gridfinity system is well documented, to say the least, and we've covered it on this channel many times before. In fact, my first ever video on this channel was actually a list of Gridfinity pro tips, so check that one out here if you haven't already. But I bring up Gridfinity for a few reasons. First, it is the ultimate stuck indoors project, requiring no outside hardware except for the optional magnets, which personally I never use anyway. But beyond that, because Gridfinity is a fully open source project, there have been a lot of updates and improvements since my last video. And Gridfinity has moved out of the workshop with models for organizing your kitchen, your makeup drawer, your writing desk, and much more. I even used the highly economical Gridfinity light bins to organize my perennially disorganized bathroom drawer. And, I mean, just look at it. Additionally, now that the improved cut feature is available in all the major slicers, you no longer have to deal with hand trimming or gluing base plates down in your drawers if they're not an exact fit to keep them from sliding around. You can actually just cut them to the exact dimensions you need, plus you can find half-width bins out there to use up that extra space as well. I love Gridfinity so much that I literally built this custom drawer in my workspace just to house Gridfinity because the puny drawers in my rolling tool cart were not cutting it. And at some point, I'm probably going to cave in and tackle my disastrous kitchen drawers as well, though that's going to have to be an entire rainy week, I think. Speaking of 3D printed organization systems that I've admittedly talked about ad nauseum on this channel, let's really quickly revisit the Honeycomb storage wall because I have some hard-won lessons that I need to share with all of you. Now, for those of you who haven't seen the 2 or 3 videos where I talk about this setup, the idea is really simple. It's another fully open source, 100% 3D printable project, except for the screws to mount it to the wall. And again, it has thousands of readily available models for pretty much anything you could wish to, in this case, mount on your wall. Sounds good, right? And it is. And as you can see, I've kind of let this stuff take over my life. It's at home, it's at the workshop. It's kind of like Visa. It's everywhere I want to be. But when I put up the massive 3x2 meter wall on my main set, I learned a few very painful lessons that I do need to share with all of you. Now, you might have noticed that that wall over there isn't exactly straight. And in certain areas, I've had to force pieces in, meaning that they are under constant tension. And by the way, I'm sorry if you didn't notice it before, because now, like me, you will never be able to unsee it. I certainly can't. Now, this crookedness isn't because I don't know how to use a bubble level, it's because drilling into concrete isn't an exact science, and there is a certain amount of imprecision in mounting these, either due to give or due to leaving small gaps when mounting. The bottom line is, even though I caught this mistake as the wall was going up, I actually couldn't do much to fix it short of re-drilling dozens of holes into reinforced concrete, which would inevitably be only 1 or 2 millimeters off, meaning they would merge with the existing holes. Look, I don't want to talk about it, okay? So how can you prevent being a dummy like me, and how did I mount this wall? Well, it's actually really simple. You assemble the pieces in advance, or at least a few of them. Instead of mounting one piece at a time and then hoping and praying that your holes are accurate and having zero flexibility once they aren't, I suggest assembling at least the center few pieces of your grid in advance, for example, on a table or on the floor. And then you can use a bubble or laser level to place it exactly how you want it. This makes it incredibly easy to get the entire thing level with no annoying tension between the segments. Now, additionally, I do want to point out that you don't need to waste kilos and kilos of filament printing the entire thing solidly like I did on my other wall. Unless you plan to put tons of weight on it, it's actually fine to have a little bit of infill. Just make sure that if you're going to print them in a stack, such as I did on my Bamboo Lab printer with AMS, you do need to fill in the top faces of the thick side, or you will end up with this effect. Or you could just print only 1 or 2 at a time to ensure that you have filled up the top faces. Also, on the topic of stacking, I've done extensive testing now comparing Bamboo Lab's support for PLA versus PETG, and hands down, it is better to use PETG for printing them stacking. I can honestly say that I am still picking away little pieces of the PLA support material that are stuck to my panels, whereas PETG generally comes off easily as just one piece. So there you have it, a handful of projects to level up your workspace and keep you creating no matter the weather. Before I let you go, I want to once again take a moment to thank PCBWay for sponsoring this video and Kexeld for sending over kilos and kilos of their wonderful filament for me to use in this project, that project, and a bunch of other project videos. Oh, and of course, I want to thank both my Patreon and YouTube members for helping pay the bills. And an extra special thanks to our Nylon and Peak members, Chip Cox, 2 Crazy Ketos, and Amir Khen. Thank you guys so much. That's all for this week, but I'll see all of you on the next layer.